Okay, how are we doing? I'm going to go over the next part of wireless transmission. I call it wireless communication sometimes, don't I? Wireless transmission. So first of all, this is the FM stuff, frequency modulation. So the modulation index is that beta value. So let's just get my pen out. It's that beta like that. It's on the data sheet, which I can show you in a moment. But it's basically the frequency deviation, delta FC, divided by the information. So frequency deviation, this one is 56. I can put times 10 to the 3. However, I know that the deviation is 12k, so the k's would cancel out anyway, won't they? 4.67 is unitless because it's frequency over frequency. Bandwidth, you've got a couple of equations for bandwidth. Let me just show you from the data sheet. There you go. So there's a couple of equations you can use there. One with the deviation and the information, which I've just used, or you could use the beta value, which we just calculated. So it's entirely up to you, really. So I'm going to go for the first one. So twice delta FC plus Fi. So in this particular case, it's twice 56 plus 12. Close your brackets. Put that into your calculator. Press your equals, and it'll be 136 kilohertz. Okay. Hopefully that's not too bad for you. Right, next one. This is the one where, if you remember, we did this in class. You have to look for one cycle. So to calculate the frequency of the sine wave used to modulate the carrier, that frequency is the lower one. So we look for one cycle. So we take a decent point. I'm going to take from there to there. So from there to there is 4 microseconds. So the time period for the information is 4 microseconds. So therefore the frequency is 1 over 4 times 10 to the minus 6, which is 250 kilohertz. Okay. Then the carrier frequency is the higher frequency. So if you go wrong, and you decide that was a carrier, you'll see that the higher one is obviously the higher one you get is always a carrier. So it's dead easy. How many of these happen in that amount of time? Look, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So is everybody happy that the carrier frequency is going to be 9 times higher than the information frequency, because you've got 9 cycles in that time? So I'm not even going to bother writing any equations. I'm just going to go 9 times 250. Yeah. Do it on my calculator, or has it got a mark scheme there? 9 times 250. Yep, 2.25 megahertz. Okay, that's it. So just be careful that the unit is the right unit as well. So I put mine into megahertz there. Okay. This next one. This time we've been given, well, we haven't been given the frequency deviation, but it is deviating between there and there. Just have a read of it. You've got the carrier. You've been given the signal frequency, which actually we might not need at the moment, but we need to know the frequency deviation first. So the modulation index is frequency deviation, and then over the information. So we need the information for that bottom bit. So what is it deviating from? This is tricky. Look at that. Between there and there, that's 0.04 down, 0.04 up. The total is 0.08 megahertz. So let's put it into megahertz, divided by 8 kilohertz. 8 times 10 to the 3. Okay, so they're all talking to each other now. We put them both into hertz. They talk to each other. What have we got there? 10 is the answer, and it's unitless, obviously. Bandwidth, we've got the option again. So which one should we use? Let's use twice delta FC plus Fi, shall we? So what's that? Twice 0.08 times 10 to the 6 plus 8 times 10 to the 3. So make sure that you're okay with your prefixes. Don't forget on your calculator, don't literally write multiply 10 to the power of that, but that will not work. You've got a button that says times 10 to the x. Use that button, it's by the equals sign. You have to use that button, otherwise it will not work properly. Where is it? I'm just going to look at it on there. So I get it as 176 kilohertz, or your calculator will put it as 1.76 times 10 to the 5 hertz, which is the same as 176 kilohertz. You've got an engineering button on the normal Casios. The graphical ones don't. However, I reckon if you've got a graphical calculator, you'll be good enough to be able to convert between kilo and mega anyway, because that tells me you're doing maths A level. Okay, this last one. Calculate the frequency deviation and the bandwidth. Well, frequency deviation, if you've been given a deviation per volt and you know the volts, think about it. How do you get rid of a per volt? A divide by volts. We multiply by volts. So delta FC is quite simply 15 kilohertz. I'm going to write the whole thing. Kilohertz per volt. That's per volt. Multiplied by 7 volts. Can you see that the volts would cancel therefore? So you're left with just a kilohertz. Where are we? 15 times times your 7 is 105. And that's in kilohertz. Okay. And then the frequency deviation. Oh, sorry, done that, and the bandwidth. Have we been given? Yeah, we've been given the information frequency. Don't use that as your information frequency. You use the highest one. It's a baseband. Yeah, remember, so it varies from that to that. Remember your old your doobie flips that look like that. It's this bit, the M bits. You don't use the inside bits. Yeah, if you're looking at it as a frequency spectrum. Okay. So bandwidth is quite simply twice delta FC plus Fi. You see we're using the same equation all the time. 105 plus 12. Again, I'm not putting times 10 to the 3 because they talk to each other already. So what's that? 117. Double that, 234. Okay, so that is now wireless communications complete. So you probably the AM, there's a few more things they can ask. FM, there's not as much. You will get tested on both of them. So you do need to know they are in the exam as part of the main thing. So obviously make sure you understand them all. Loads of questions. The questions for this are in ET4, so feel free to try a couple of those questions. You can always pop in and see me if you get stuck on any. Thank you very much.